Hey everyone, my name is Jonathan and I lead our ecosystem product marketing here at Firebolt. And I am excited you're here to check out this live stream series. So, this series is all about showcasing real world demos of how Firebolt connects with the tools and formats that power today's modern data stacks. So far, we've covered streaming with Estuary to create fast data pipelines. And in yesterday's live stream, we showed you how to leverage dbt and Firebolt together for powerful transformation workflows. If you're new to Firebolt, here's a quick elevator pitch. Firebolt is a high performance cloud data warehouse built for developers and engineers who need sub-second analytics on massive data sets. It's lightning fast, cost efficient, and purpose built for building data intensive and AI driven applications. And today's episode is all about Apache Iceberg, one of the fastest growing open table formats in the analytics world. Iceberg brings reliability and flexibility to the way you manage large scale data lakes, and Firebolt now natively supports querying Iceberg tables right out of the box. If you're working with open data architectures or trying to unify lakehouse and warehouse workloads, this one is for you. Now, before we dive into the demo, drop a hello in the chat and let us know what you're hoping to see today. We'd love to hear from you, where you're tuning in from, and what you're building. And with that, let's jump right into the demo. Let me bring Tobias onto the live stream here. Tobias is one of our brilliant software engineers here at Firebolt. Tobias is going to show you how Iceberg and Firebolt come together to deliver fast, flexible analytics on open formats. Tobias, the floor is yours. Take it away.
Hello from my side. I'm Tobias, software engineer at Firebolt. And in this demo, I will show you how you can run a low latency workload on an Iceberg table managed by Databricks. Let me share my screen. We're starting this demo in the Databricks SQL editor. And what we have here is a large table called user visits. So this table has, as you can see, about 6.7 billion rows, so really large table. And our goal for today is to build a to run a low latency workload on this table through Firebolt. So Databricks is great, but it doesn't really support low latency. So let's use Firebolt for this. Now we can query this Databricks table through Firebolt by using Firebolt's new Iceberg support. And Databricks has this great feature called Uniform, which exposes its tables as Iceberg tables. To enable this for the user visits table, we just have to execute this alter table statement. And then we can check in describe extended. Delta uniform Iceberg is enabled for the user visits table. Now that's it from the Databricks side. So how can we now read this table in Firebolt? For this, we need to create a location object. So the location of the Iceberg table in Databricks. And we call that amplab 1 terabyte user visits. So in the Firebolt SQL editor, we execute this create location statement where we specify it's an Iceberg table, it's the Databricks Unity catalog, and this is the table in Databricks. So it's in this workspace, in this catalog, in this schema, and the table is called user visits. Now we can execute this. Of course, I've already created the locations before so that I don't have to show the credentials here. We can check this using this information schema query. So we have two locations, the amplab 1 terabyte user visits location and the amplab 1 terabyte rankings location. So these are two tables in Databricks that we're going to query now. So let's go ahead and fetch 10 rows from the Databricks table, from the user visits table in Databricks. Okay, that's it. This is how you can read data from Databricks in Firebolt. And it was decently quick, 3.4 seconds. Let's execute it again. It's 700 milliseconds, and again, almost 700 milliseconds. So this is quick, but it's not really low latency, right? And what happens in the background is that we always need to have at least one round trip to the Databricks servers from Firebolt to understand whether somebody, for example, inserted something into the table or even dropped the table. And that means even though we execute the same query multiple times, we can't cache its result completely. And to get around this, to get to really low latency, we added this feature called max staleness. So using this feature, you can tell Firebolt, hey, it's okay if you use a slightly outdated version of the table for this query, but be super fast. So in this case, we specify a max staleness of 10 minutes. You can, of course, also use 1 minute or 30 seconds, depending on your needs. Okay, so let's execute this query with max staleness. And we see, boom, 10 milliseconds. This is low latency. Now, we can do the same on the rankings table. We also specify the max staleness here. And you can see we can also read the rankings table from Databricks. Now, it's cool that it's so easy to query data from Databricks in Firebolt. But of course, these queries weren't really that interesting. So let's do something more interesting. The dataset we're working on is the classic Amplet dataset, but it's scaled to 1 terabyte of data. So let's execute this query that gets the ad revenue for URLs with page rank 10 on January 15th of the year 2000 by the country codes. So this takes about 8.6 seconds. It's a fairly complex query. And let's see what we spent time on. If we check the query profile, we can add additional information here. This is the interesting part. So we see we have this join with the rankings table and the user visits table. And most of the time is spent in this operator that reads the rankings table. So it reads page URL and page rank. Here we read 300 million records, which is basically the whole table. Now, on the user visits table, we spent very little time, and we only read a bit less than 1 million rows. In Databricks, we saw that the whole table has 6.7 billion rows. So how come? This is because the user visits table is clustered by visit date, and we have this filter on visit date in the query. So Firebolt can then just scan the very small subset of the data and be super efficient. For rankings, we have this filter on page rank, but the rankings table isn't clustered by page rank. So here we need to scan the whole table. So if we look at the results, it's nice, but it's a bit difficult to read. So let's sort this by total revenue to see which country has the most revenue on this day. Boom, 0.04 seconds compared to 8.2 seconds before. What happened? We see, okay, Swiss has the most revenue on this day. How were we able to execute this query so fast? Again, we can check the query profile. And what happened in the background is basically this query is almost the same as the query before, right? It just changes the sort order. So our system figured out that it can reuse the result from the previous query and then just sort it and emit it to the user. So here we see we spent no time on the aggregation or any operator below. And then on the maybe cache, which is the one reading the result of the previous query, and then the sort on top of that, here we spend all the time. So this is cool. But of course, it's quite easy to be fast here. It's basically the same query as before. So let's change the query a bit more. So before we had this sum query, so sum of ad revenue. And if we change that to median, the query is quite different. So let's execute it. 120 milliseconds, super fast as well. Not as fast as before, but a lot faster than the 8.2 seconds on the first query execution above. So what happened here? We weren't able to cache the full result, right? Or to reuse the full result. Let's check again the query profile. And the interesting part is again here. So we have this join between user visits and rankings. And before you saw that the very expensive part was the scan of rankings. So scanning page URL and page rank. Now we spend no time on this. Instead, the expensive or the most expensive operator is scanning the user visits table, which was super quick before. In fact, we were able to cache the whole build side of the join, which was the expensive side. And during query execution, we only had to execute the cheaper side of the join, which is super fast because we were able to prune away all of the data. So it's quite easy to forget that you're querying Iceberg here, right? Everything is super fast. We are able to cache results, sub-results. We have 0 round trips to any other servers, so we can have low latency queries with 100 milliseconds or 50 milliseconds or sometimes even 10 milliseconds latency on Iceberg. That was my demo. Thank you. And back to you.
Thanks a ton, Tobias. Incredibly powerful stuff. I mean, it's amazing how easy it is to query Iceberg tables with Firebolt and still get sub-second performance, especially for teams leaning into open formats and lakehouse architectures. And a big thank you to everyone who joined today's live stream and anybody else who's catching this as a replay. If you want to experience Firebolt's lightning fast engine for yourself, head over to go.firebolt.io. We're going to leave a link to that in the comment section or maybe in a CTA card. But you can launch your own Firebolt workspace and try it out for free. No credit card required at all. And that's a wrap for this episode, this live stream. But please be sure to follow us on wherever you're tuning in from, whether it's YouTube or LinkedIn, so you don't miss out on the next episode. More awesome integrations to come and use cases on the way. So until next time, keep building and stay curious.